children, welcome to Grade 8 Mathematics Classroom. Today we are going to talk about the 30th lesson of your mathematics textbook, that is tessellation. So quickly take out your mathematics textbooks and turn to page number 159. There you can find the lesson tessellation. Right. First, before moving to the lesson, I thought of telling you what you are going to learn after studying this lesson. So, by studying this lesson, you will be able to identify what regular tessellations and semiregular tessellations are, select suitable polygons to create regular and semiregular tessellations, and create regular and semiregular tessellations. Right. Now, I am going to give you some pictures. Just check whether you can see a pattern there. Are these tessellations? We will see. Here we can see a giraffe in this picture. So, we can see a pattern in his skin. So, is it a tessellation? Just think a little bit. Now, here I have got a tortoise. What can you see there? Can you see a pattern? So, once again think, is that a tessellation? Right. Now, what is this? Yes, it is a beehive. Isn't that so? So, here we have two pictures of a beehive, and what can you see there? Can you see a shape that you already know? Yes, we can see some hexagons there. Isn't that so? So, is that a tessellation? We will see. Right, these are some of the things you can see in your day-to-day life. Those are there in the nature. So, we will now move on to some man-made tessellations. So, first of all, have a look at this picture. Here you can see two beds with beautiful bed sheets. Isn't that so? There we can see two types of tessellations using squares. They have used different colors to create beautiful patterns. Isn't that so? So, are these tessellations? Yes, they are. They are tessellations. Here they have used the shape of square to create beautiful tessellations. Isn't that so? So, now can you remember the tessellations you have created in grade 7? Your teacher might have asked you to make beautiful wall hangings as an activity in grade 7, isn't that so? So, you also may have created beautiful tessellations in grade 7. So, we will move on to some more tessellations. Here, I have got a chair. What can you say about the material they have used to decorate the chair? They are also, can you see a tessellation? There we can see two types of figures in that material, and those figures are nicely designed as a tessellation. Isn't that so? So, now look at the second one. What is that? Yes, it is a cushion. Isn't that so? So, they have used a material with a beautiful pattern. So, are these tessellations? Have you gone through these in your day-to-day life? Think a little bit. Now, what are these? Now, it's here in this picture we can see a kitchen. Isn't that so? Now, here I want you to have a look at the floor tile of the kitchen. What can you see there? I can see some squares and rectangles, and the squares and the rectangles are nicely placed as a pattern. Isn't that so? So, once again we can see a beautiful tessellation there. The rectangles are in two colors, squares are in another color. They have nicely placed the squares and rectangles to create a beautiful tessellation. Right. Now, have you seen these in your day-to-day life? What are these? Here we can see some bricks, isn't that so? They have fixed these on the floor to create a beautiful pattern. You may have noticed these in park or walking paths. You may have noticed these types of tessellations. So, we will move on to another one. Here once again I can see some hexagons there. At the same time there are some squares as well. So, once again they have placed hexagons and squares to create a beautiful patterns. Isn't that so? So, can you consider this pattern as a tessellation? Think a little bit. Think about the things you have learnt in grade 7 and then just think a little bit. Can you consider these patterns as tessellations? Right. Now have a look at this picture. Here there is a wall, isn't that so? You can see some bricks there and you can see the shape of rectangles there, and it's formed nicely. It's creating a beautiful pattern. Once again we can consider these as tessellations, isn't that so? Now what about this? Have a good look at this picture. Here I can see two types of patterns. First one is they are on the floor. Can you see? There is a mat on the floor. So, in the mat I can see some rectangles in two different colors, white rectangles and black rectangles. So, they have arranged those rectangles to create a beautiful pattern. Once again, it is also a tessellation. Now, have a look at the wall. What can you see? Can you see a pattern there? I can see a pattern. What about you? I can see some semicircular shapes, some rectangular shapes, some triangular shapes. They have beautifully fixed those shapes to create a beautiful pattern. Once again, that is also a tessellation. Right. Now have a look at this roof. Here I can see some triangles in this roof. I have another picture for you according to the same roof. In both pictures you can see triangles on the roof. So, those triangles also create a beautiful tessellation. Isn't that so? Right. Now, we have gone through some examples for tessellation. So, can you remember what you have learnt in grade 7? What is tessellation? We can say that's an arrangement of shapes. You can use one or more shapes, but there is a must. What is that? You should not have gaps or overlaps between two shapes in a tessellation. So, we can define tessellation as covering a certain space using one or more shapes in a repeated pattern without gaps and without overlaps is called tessellation. I'll say it once again. Covering a certain space using one or more shapes in a repeated pattern without gaps and without overlaps is called tessellation. Right. By now we know what tessellations are. So, we will have a look at some more tessellations and we will try to identify what shapes they have used in these tessellations. Right. Have a look at the first one. There I can see some triangles. The triangles are colored in two different colors. Isn't that so? Some are colored in red and some are colored in yellow to create a beautiful pattern. So, they have used just one shape and in two different colors. That is also a tessellation. Then have a look at the second tessellation, second figure. Once again they have used only triangles, but this time they have used 4 different colors to create this tessellation, to create a pattern. This pattern is called a tessellation using one shape. Now have a look at this pattern. Here once again we have only squares, but in 2 different colors. Here we can see yellow and dark ash squares. Isn't that so? So they have changed the colors to create a beautiful pattern. Once again, that is also a tessellation. So we will move on to another one. Have a look at this. Once again we have a pattern only with squares. This time they have colored the squares in 3 different colors: yellow, orange and red. Right. They have used these colors once again to create a beautiful pattern, that is also a tessellation. Right. What can you say about this picture? Here you can't explain the shape of the figures they have used, because it's not a shape that you have learnt in mathematics at school. But they have used the same shape throughout the picture. Isn't that so? Therefore, we can consider this also as a tessellation. To make it more beautiful, they have used more colors. Isn't that so? Right. Once again, there is a pattern here. Here we can see only curved edges in this pattern, and they have colored the patterns in blue and yellow. Have you noticed that they have used only one shape throughout the pattern? Okay, right. Once again, this is also a tessellation. Right. Now what about this? Here I can notice 3 types of shapes. I can see a square, I can see some triangles, I can see some hexagons. They have colored the hexagon in yellow, they have colored the squares in blue, and they have colored the triangles in red. Isn't that so? Right. Once again, we can consider it as a tessellation. Right. Now have a look at the other picture. Here I can see some squares, triangles and some quadrilaterals. Isn't that so? Now the triangles are in green color and the squares are in brown color, and the quadrilaterals are in grey color. Right? So once again we can consider that one also as a tessellation. Right. Now we have gone through so many examples for tessellation. So now we are going to talk about the types of tessellations. In grade 7, you have learnt on 2 types of tessellations. Can you remember those? Yes, you have learnt on pure tessellations and semi-pure tessellations. So this year also we are going to learn on 2 types of tessellations. Those are regular tessellations and semi-regular tessellations. So up to now we are going to learn 4 types of tessellations. Those are pure tessellation, semi-pure tessellation, regular tessellation and semi-regular tessellation. Right. We will start with pure tessellation. That topic is discussed in grade 7 also, but we will go through the things you have already learned. Then it will be easy for you to catch up with the new lesson contents. Okay. Right. Now what is a pure tessellation is? So first of all we will define a pure tessellation. We can define a pure tessellation as a tessellation consists of only one shape. That means we are using only one shape to create these pure tessellations. Right. We will go through some examples. Have a look at this. The complete figure is filled with triangles in two colors. You can see triangles in blue color and some triangles are in red color. Isn't that so? Now, we have used two colors, but the only shape you have used throughout the tessellation is triangles. Right. Now, here, as I have told you before, we have used triangles in two different colors, blue color triangles and red color triangles. Right. We will move on to another example. Now, here we are having, once again we are having only triangles, but in two different colors. What are the colors we have? We have pink color triangles and triangles in light blue. Isn't that so? Right. Now, once again it is a beautifully created tessellation. So, we will move on to the next one. Once again we have only triangles there. We can name those triangles as right angle triangles. Isn't that so? You have learned the types of triangles in previous grades. Right. Now, once again here we have right angle triangles of two different colors. Some are in yellow color and some are in red color. Right. Now, have a look at this picture. What is the shape that you can see? Yes, those are quadrilaterals. Isn't that so? Now, throughout the picture, we have only the same shape but in different colors. There are quadrilaterals in blue color, there are quadrilaterals in red color, and some quadrilaterals are there in yellow color and some are there in green color. Isn't that so? Once again, we can consider it as a pure tessellation because they have used only one shape throughout the pattern. So, they have used only one shape, therefore, we can name it as a pure tessellation. Right. Now, have a look at this one. What is the shape that you can see there? Yes, once again you are correct. Here we can see only rectangles. Isn't that so? The shape they have used is rectangles but in two different colors. Some are in blue and some are in green. Right. As they have used only one shape, once again we can say it is also an example for pure tessellations. Right. Now, have a look at this one. Here we have only squares. Once again they have colored in two different colors, blue, dark blue and light blue. Right. We have got only squares, therefore, we have used only one shape to create this tessellation. So, we can say this is also an example for pure tessellation. Right. Now, have a look at this pattern. Here, what is the shape you can see? Have you noticed the shape? How many sides are there in that shape? We will count 1, 2, 3, 4, 5. There are 5 sides in that shape. So, the shape we have used is called a pentagon. Right. Now, here we have used only pentagons in several colors. As I have mentioned you before, if we have used only one shape to create a tessellation, we can name that tessellation as a pure tessellation. Now, therefore, we can say this is also an example for pure tessellations. Right. Now, look at this picture. When you are looking at this picture, what comes to your mind? Can you remember the beehive I showed you in previous slides? Is it in the same shape? Yes, it is, because in beehive we have noticed some hexagons. Here also this pattern is created using hexagons. Here we can see hexagons in 3 different colors. Some are in green, some are in yellow and some are in red. Therefore, the only shape you have used here is hexagons. Once again, if you have used only one shape throughout the pattern or throughout the tessellation, we can say this tessellation is an example for pure tessellation. Right. Now have a look at this one. Once again, we can see only hexagons throughout the pattern. Isn't that so? So there are no overlaps, no gaps between shapes. Therefore, it's a tessellation. The hexagons are colored in 3 different colors. We can see blue color hexagons, yellow color hexagons and red color hexagons. Once again, we can say they have used only one pattern or one shape throughout the pattern or throughout the tessellation. Therefore, this is also an example for pure tessellations. Right. Now have a look at this one. We are creating a tessellation using only one shape. Right. Here also we have used only one shape. So, we can say this is also an example for pure tessellations. Right. What can you say about this picture? Here, we can't say a name for the shape they have used. Have a look at the shape. This is the shape that we have used throughout the picture. We have colored the same shape in many different colors to create a beautiful pattern. But still, we are using the same shape throughout the pattern. Therefore, throughout the tessellation, we are having the same shape. That means this is also an example for pure tessellations. Now, what can you say about this one? At once, when you just look at the picture, you might think, oh, they have used 2 different patterns or 2 different shapes in this pattern or in this tessellation. We will see, have they used 2 different shapes? I am having doubt on that. We will see, this is the shape that they have used. Isn't that so? So, what about the other shape you can see? They have rotated the same shape and once again fixed it. Right. Now, that means throughout this pattern also they have used the same shape. That means in this tessellation we can notice only one shape in many different colors. Therefore, we can say this is also an example for pure tessellations. Right. Now, we have discussed many things on pure tessellations. We have discussed almost all the things you have discussed in grade 7. So, we will summarize the things we have learned under pure tessellations. First, we said pure tessellation is a tessellation created using only one shape. Both rectilinear shapes and curved shapes can be used to create pure tessellations. Right. Now, that is about pure tessellations. Then in grade 7, we have discussed on semi-pure tessellations. So, once again we are going to recall the memory on semi-pure tessellations now. Now, what are semi-pure tessellations? Those are also tessellations, but this time semi-pure tessellation consists of 2 or more shapes. Pure tessellation had only one shape throughout the pattern or throughout the tessellation, but here in semi-pure tessellation you can use 2 or more shapes. So, we will define semi-pure tessellations as a tessellation consists of 2 or more shapes. Right. We will move on to some examples. Now, have a look at this picture. What are the shapes used in this tessellation? What can you see? You may be correct. We will check. This is the first shape we can see. What is that shape? That is a square. Next, we have used parallelograms. Now, we have used squares and parallelograms throughout this tessellation. We have used two different shapes, therefore we can say it belongs to the type of semi-pure tessellations. Right. Now have a look at this tessellation. Now what are the shapes that you can see there? We can see squares, we can see equilateral triangles. Isn't that so? There are squares in two different colors, in blue and green. There are equilateral triangles once again in two different colors, in green and blue. Now we can say throughout this tessellation we have used two different shapes. Therefore, if you have used two or more different shapes, it belongs to the type of semi-pure tessellations. Therefore, we can say this is an example for semi-pure tessellations. Right. Now have a look at this one. Now what are the shapes you can notice here? We'll take one by one. Right. Now it's a rectilinear plane figure. It's like a star, isn't that so? They have colored it in red color. The other shape we can see here is quadrilaterals. Right. Here we have used two different types of shapes. Therefore, we can say this is also an example for semi-pure tessellation. Right. Now have a look at this picture. Now what are the shapes you can see there? We'll see. Some shapes are in yellow color, some shapes are in grey color, some shapes are in light blue color. So we'll take one by one. There we can see squares in the pattern or in the tessellation, and then we can say hexagons in this tessellation. Finally, we have triangles in this tessellation. So we have got three types of shapes in the tessellation. Therefore, we can name it as a semi-pure tessellation. Right. Now we have discussed more about semi-pure tessellations. So that is also a lesson you have learnt in grade 7. So what were there in semi-pure tessellations? First we said semi-pure tessellations consist of two or more shapes. And then we said in semi-pure tessellations we have both rectilinear and curved shapes. We can use both of them. Right. Now we have discussed what pure tessellations and semi-pure tessellations are. In grade 7, finally you have discussed how to create beautiful patterns using the knowledge of tessellations. So we will go through some patterns that you may have created in grade 7. Right. Now I am going to create a beautiful pattern. Have a look at these slides. Right. I have used just a shape to create the tessellation. Throughout the tessellation, I can notice only one shape. Now, by now you know what name you can give to this tessellation. What is the name that you can give? Yes, that is a pure tessellation, because throughout the tessellation you have got only one shape. So, this is a pure tessellation. Right. Now have a look at these pictures. These are the figures some of the students have created in grade 7 using the knowledge of tessellations. Isn't that so? The first one, those are like some fish. Isn't that so? The same figure is repeating without having gaps or overlaps. Right. Now these are here in the second picture, it's like an animal. But the same figure is repeated throughout the tessellation. Right. Now, both of them are pure tessellations. Right. Now, have a look at these ones. Here also they have, when we talk about the first one, it's like a veil, isn't that so? The same veil is there throughout the tessellation but in different colors. Second one, here it's like birds. Once again, the same bird is there in two different colors. When you look at this one, it's like a dog, isn't that so? The same figure of dog is used in two different colors. Here, what is the animal you can see? It's like a bird. The same bird figure is used throughout the tessellation but using some different colors. Right, we'll move on to some more figures. Now, these were the basic figures you have used in tessellations. First one, we have only squares. Second one, we have only triangles. Third one, we have only hexagons. But there is a difference. First one, have you noticed, squares means all the sides are equal in length and all the interior angles are equal in magnitudes. Then what can you say about the triangles used in the second figure? All the sides, all three sides of the triangles are equal in length. That means the interior angles of those triangles are equal in magnitude. Then what can you say about the final figure? It consists of hexagons with all six sides are equal in length. That means all the interior angles are equal in magnitudes. Therefore, we can say these tessellations are consist of regular polygons. Right. Now, from this point onwards, we are going to move on to the grade 8 lesson. Right. Before learning about the other two types of tessellation, I want you to know about what regular polygons are. You have already learned that, but we'll recall the memory. What is a regular polygon? We can define a regular polygon as a polygon with all the sides are equal in length and all the angles are equal in magnitude. We'll take one by one. First one is equilateral triangle. There we have got three sides. Here all the sides are equal in length. I have put some strokes to mention that all three sides are equal in length. Then if all three sides are equal, what happens to the interior angles? Those are also equal. Therefore, the magnitude of an interior angle should be equals to 60 degrees. Right. We will move on to another figure. Here we can see a square. A figure consists of four sides. Now here all four sides are equal in length. What can you say about the angles? All four angles are equal in magnitude. Right, the magnitude of the angles are equal. So we can say magnitude of an interior angle is equals to 90 degrees. Then we will move on to the figure or rectilinear plane figure consists of 5 sides. That is pentagon. Here I have mentioned a pentagon of all 5 sides are equal in length. Therefore, we call it as a regular pentagon. There we have the magnitude of all 5 interior angles are also the same. So, the magnitude of an interior angle is equals to 108 degrees. Right. Next, we will move on to the rectilinear plane figure with 6 sides, that is hexagon. When all 6 sides are equal, we call it as the regular hexagon. Here all the length of all 6 sides are equal. Therefore, the interior angles of all, therefore, the magnitude of all interior angles are equal. So, we can say the magnitude of one interior angle is equals to 120 degrees. Right. Then we will have a look at regular octagon. Octagon means once again a rectilinear plane figure consists of 8 sides. here it's a regular octagon, that means all 8 sides are equal in length. The magnitude of all interior angles are equal. So, we can say the magnitude of an interior angle is equals to 135 degrees. Right. Then we will have a look at regular dodecahedron. Dodecahedron means once again a rectilinear plane figure consists of 12 sides. As it is the regular dodecahedron, we can say all 12 sides are equal in length. Once again, the magnitude of the interior angles are the same. So, we can say the magnitude of one interior angle is equals to 150 degrees. Right. Now, we have learnt about regular polygons. Now, here we will move on to the next session of the lesson, that is about regular tessellation. Right. Here, what is regular tessellation? Previously, we have learnt on regular polygons. In regular tessellation, we use only regular polygons. So, first of all, we will move on to the definition of regular tessellation. A tessellation created using only one regular polygonal shape is known as a regular tessellation. I will say it once again. A tessellation created using only one regular polygonal shape is known as a regular tessellation. And we says a vertex of one geometrical shape should not be on a side of another geometrical shape. I am going to discuss the second point later on. So, we will take the first point, that is a tessellation created using only one regular polygonal shape. Previously, we have learnt about regular polygons. So, here as I have told you, in regular tessellations, we are going to use only regular polygons. The most important thing is we are going to use only one regular polygon throughout the tessellation in regular tessellations. So, we will move on to some examples. Have a look at this. Here we have used only equilateral triangles. Using equilateral triangles, we have created a beautiful tessellation. Here we have used two different colors, black and red. Right. Now, as I have told you, equilateral triangle is a triangle of all three sides are equal in length and all three interior angles are equal in magnitude. Therefore, equilateral triangle is a regular polygon. Here we have constructed this tessellation using only one regular polygon. Therefore, we can say this is a regular tessellation. Right. We will use some squares now. Have a look at this picture. Now, we are creating a tessellation using only squares. Once again, as I have told you, square is a rectilinear plane figure consists of 4 equal sides. Therefore, a square is a regular polygon. That means, here we have used one regular polygon throughout the tessellation. Therefore, once again, this is an example for a regular tessellation. Now, here we are using pentagons, not just pentagons. These are regular pentagons. That means, all 5 sides are equal in length. Now, I was just trying to create a beautiful tessellation using regular pentagons. What has happened? I have some gaps between two shapes. Isn't that so? So, can I make a tessellation using regular pentagons? No, I can't. Why? In tessellations, you should not have gaps or overlaps between two shapes. Now, here between two figures, I have got some gaps. Therefore, I can't create a tessellation using regular pentagon. So, that means using a regular pentagon, we cannot create a regular tessellation. Right. Now here I have used regular hexagons. That means all 6 sides are equal in length in these hexagons. Now what can you see? We have created a beautiful tessellation using regular hexagons. Therefore, we can say that using regular hexagons, we can create a regular tessellation. Therefore, this is an example for regular tessellation. Now, next I am going to move on to the second point that we have learned under regular tessellation. That is, a vertex of one shape should be coincide to the vertices of the other shapes. Right. What does that mean? I am going to explain it now. So, have a look at these pictures. Here, what can you see? We will take the first one. There, what can you say about the vertices? There, all the vertices coincide on one point. Then we will have a look at the second one. There we have only squares. It is a regular tessellation. Once again, all the vertices coincide on one point. What can you say about the last one? Here we have only hexagons, regular hexagons. That means it is also a regular tessellation and all the vertices are coincide on one point. I will explain it furthermore. Right. Now have a look at this picture. It is a regular tessellation using equilateral triangles. We have colored the equilateral triangles in 2 colors, red and light blue. Right. Now I have marked a point here. What is this point? Okay, it is the vertex point. Right. All the vertices of the triangles coincide in that point. So, this feature is a must in regular tessellations. Right. What can you say about this picture? Here, can you notice a vertex point? We have used some equilateral triangles here. Therefore, it have to be a regular tessellation. But can you notice a vertex point there? We will see. The vertex of one triangle is on the side of another triangle. Right. Therefore, we can't have a proper vertex point there. That means this cannot be taken as a regular tessellation. So, here I have asked you a question. This is not a regular tessellation. Why it is not a regular tessellation? Therefore, we can say because a vertex of one shape is on the side of another shape. Therefore, it is not a regular tessellation. Right. Once again, there is a question for you. So, have a look at these pictures. Which figure represents a regular tessellation? I have given you 2 figures. Both figures consist of squares. That means all 4 sides are equal in length of those shapes. So, when we talk about regular tessellation, you should have regular polygons. Here I have used regular polygons, but one figure consists of a regular tessellation, the other figure consists of, other figure is not a regular tessellation. So, you have to choose which one is consist of a regular tessellation, A or B. We will see. Have a look at picture A. Once again, here we have got a regular polygon, so no issue on the first point. So, we have to think about the second point now. All the vertices should coincide on one point. So, can you clearly mention a vertex point in figure A? Yes, we can. That means figure A consists of a regular tessellation. Right. Now, we will have a look at figure B. What can you say about that? That tessellation also consists of regular polygons. It consists of squares. But can you observe a vertex point there? No. The vertex of one polygon sits on the side of another polygon. Therefore, we can't notice a vertex point. That means it cannot be a regular tessellation. Right. Now we have learnt about regular tessellations. So, we will once again have a look at what we have learnt on regular tessellations. Right. When constructing a regular tessellation, each vertex of all the shapes should coincide on a vertex point. Sum of the magnitudes of the angles around each vertex point is 360 degrees. If 360 degrees is divisible by the magnitude of an interior angle of a regular polygon, then using that regular polygon we can create a tessellation. Right. Now we are going to create tessellations. Now we have got some instructions how to create a tessellation, how to create a regular tessellation. So we will create some regular tessellations. Right. There are only 3 types of shapes that we can use to create regular tessellations. We have got so many regular polygons, but as we have noticed in previous slides, using a regular pentagon we couldn't create a regular tessellation, isn't that so? As we have noticed previously, we couldn't create a regular polygon using regular pentagons, isn't that so? Why is that? The reason is, if 360 degrees is not divisible by the magnitude of an interior angle of a regular polygon, then we cannot construct regular tessellations using those regular polygons. So, as I have mentioned here, we have only 3 shapes or 3 regular polygons that can be used to create regular tessellations. So, what are those 3? First one is equilateral triangle. Here the magnitude of the interior angle of an equilateral triangle is 60 degrees. Therefore, 60 degrees multiplied by 6 is 360 degrees, or else we can take it as 360 degrees divided by 6, it is 60 degrees. Therefore, 60 is a 360 is a multiple of 60. Therefore, using equilateral triangles we can construct regular tessellations. Right. Here is an example for the regular tessellations we can use or we can create using equilateral triangles. Right. Next, using squares also we can construct regular tessellations. The reason is the magnitude of the interior angle of a square is 90 degrees. So, we know that 90 degrees multiplied by 4, it is 360 degrees. Therefore, we can create a regular tessellation using squares. Now, here I have mentioned the vertex point also. Right. Next one is regular hexagon. Once again, the interior angle of a regular hexagon is 120 degrees. So, when we multiplied 120 by 3, it is once again 360 degrees. Therefore, we can create a regular tessellation using regular hexagon. Here, I have mentioned the vertex point also. Right. Now, there is a question for you. We will read it. Can we construct a regular tessellation using regular pentagons? We will see. Now, the interior angle of a regular pentagon is 180 degrees. So, when we multiply it by 3, that is 324 degrees. That is less than 360 degrees. So, we will multiply the interior angle by 4. Once again, that is 432 degrees. That is greater than 360. So, we can see we cannot make a regular tessellation using a regular pentagon. Right. Now, here as I have told you, there are only 3 types of regular tessellations that we can create or we can construct. So, first one is using equilateral triangles, second one is using squares, and the third one is using regular hexagons. Right. Now, we have to think about the order of polygons around the vertex point. Here in regular tessellation, the order should be always equal. So, we will take the vertex point as A. The order of polygons around point A is always, here 3 means we have 3 sides in a triangle. So, the order of polygons around point A is 3, 3, 3, 3, 3. So, each and every vertex point, the order is the same. So, it can we can create regular tessellations using equilateral triangles. So, this is a regular tessellation. Now, when we consider about point B, there the order of polygons is 4, 4, 4, 4. Once again, each and every vertex point, this order is the same. Therefore, we can say this is also a regular tessellation. Right. When we consider about the order of polygons, here it's around point C, the order is 6, 6, 6. Once again, 6 means the number of sides in the polygon. Therefore, this also can taken as a regular tessellation. Right. Now, we will quickly move on to semi-regular tessellations. Here also, we are going to use only regular polygons, but this time we are going to use 2 or more regular polygons to construct semi-regular tessellations. Right. So, semi-regular tessellation is the tessellation created using 2 or more regular polygons and such that the same polygons in the same order surrounded each vertex point are called semi-regular tessellations. Right. Now, once again, the order of polygons should be the same on every vertex point in this semi-regular tessellations. Right. Now, these are some examples for semi-regular tessellations. We will quickly move on to the order of polygons there. Here, the order of polygons around point A is 3, 3, 3, 4, 4. So, when we mark another vertex point, once again, the order of polygons around point B is 3, 3, 3, 4, 4. So, the order is the same. Therefore, we can consider this as a semi-regular tessellation. Right. Now, once again, there is a question for you. Is this tessellation a semi-regular tessellation? So, to find that, we have to have a look whether they have used regular polygons here. Yes, they have used regular polygons, regular hexagons and equilateral triangles. But what about the order of polygons? We have marked 2 points there, point A and point B. Around point A, order is 3, 6, 3, 6. Around point B, the order of polygon is 3, 3, 6, 6. Therefore, we can say the order is different in 2 vertex points. So, this cannot be considered as a semi-regular tessellation. There are only 8 types of semi-regular tessellations. So, here I have mentioned all 8 types. So, look at the first one. There we have used only regular hexagons and equilateral triangles to construct this semi-regular tessellation. When we look at the second one, there we have only squares, equilateral triangles and regular hexagons. In the third one, we have got squares and regular octagons. In the fourth one, we have equilateral triangles and squares only. In fifth one, we have got regular dodecahedrons and equilateral triangles. In the sixth one, we have got equilateral triangles and squares. And in the seventh one, we have got regular dodecahedrons, squares and regular hexagons. Right. Finally, in the 8th one, we have got regular hexagons and equilateral triangles. Right. Now, we have discussed on semi-regular tessellations. Right. Before winding up the lesson, I thought of summarize the things what we have learned today. First of all, we have learned what a tessellation is. A tessellation created by using only one shape is called a pure tessellation. A tessellation created by using two or more shapes is called a semi-pure tessellation. A tessellation created by using only one regular polygonal shape is called a regular tessellation. A tessellation created using two or more regular polygons and such that the same polygons in the same order surrounded each vertex point are called semi-regular tessellations. Right. Now, that is what we have learned today. Right. Now, it's your time to do the homework. We have got some exercises in your textbook. So, please do all the exercises to be thorough with the lesson. And if you have missed the lesson or if you want to go through the lesson once again, you can go through the lesson through the YouTube channel, Channel NIE. Right, that's it for the lesson. So, we'll see you in another lesson. Take care.